If it looks like there's a bit of construction going on in the background, don't mind it. I just like to change things around every now and then. But that's not what we're talking about today. Today we are talking about making PCBs again. Last time I showed you what the process looks like if you're using a CNC router and actually route out copper. This time I'm going to be showing you how to use a pen and a 3D printer or any other CNC machine to do it without actually making any dust. Now this is by far not a new concept. Basically the RepRap project is what got 3D printing started. It's what all our 3D printers today are kind of based on, and the general idea was to make a machine that could replicate itself. 3D printing was just like, it was the best solution, but it was never about 3D printing specifically. And that meant that there were a bunch of different kind of solutions building on top of just an XYZ coordinate system, including making PCBs with a pen. So basically how PCBs are made normally, if you don't route them with a CNC, is you have a photoresist on these that gets exposed, and that gets developed and washes away the unexposed photoresist, that gets etched, and then you have a finished PCB more or less. And to make that process a bit simpler and to take out some of the steps, the RepRap project, and I'm sure others before it, had the approach of using a pen to draw on your etch resist. So I could literally just draw on like a rudimentary layout on this and, drop it in some etching solution, and anything that isn't covered with the red ink gets etched away. Anything that is covered remains, and that's my traces that are left behind. That's really all there is to this idea. It's a rather simple process. All you need is a pen, some way to mount it, a machine that can move in XYZ, aka 3D printer, and then some way to drill out holes after the etching is done. Okay, so the mount that I printed here is this two-part thing. It has a few more parts that I'm not going to be using. But basically, you take the pen, it gets mounted into this slide. It has a few clamping screws up here, 2 mounts for LM80U linear bearings, the same one that are being used on every other 3D printer. And this is basically just going to slide in this holder up and down. The only reason for using this versus just taping the pen onto a carriage is that this is going to be kind of elastic. So if you don't nail the Z height, you don't smoosh the pen, and if you're a bit too high, you don't just draw air, but this kind of has some give to it. Now, this is a mount that is supposed to fit the Prusa i3, but I don't think it actually fits the Mark II or Mark III, the newer versions. I checked the hole pattern, it doesn't really line up. So what I'm going to be using instead, and as always, this is going to have a bit of a quick and dirty flavor to it. I'm going to be using the Ender 3, the hot, and then this one is shot anyways. And I think I'm just going to stick it to the side of the shroud. And it's rigid enough to a point where the pen is not going to drag around or get deflected when we draw something on it. So I think this is going to be a really good platform for trying this out. So I do need to grab some 8mm rails with the correct length for this, some LM80U bearings, some screws, nuts to clamp the pen. So let's do that right now. So these by themselves should be plenty tight. I mean, they're not going to fall out, but I'm still going to give these ends a dab of super glue just to be safe and to make sure that once this PLA relaxes, these don't get super sloppy and loose. And I actually forgot that this slide needs to be installed first. Fantastic. Well, I guess I can still mount it on this side and just move the clamping mechanism to the other side. 1 second. Look at how flush these are. These look really nice. So that's the pen mounted. This feels good. It's not like super duper rigid, but should be more than good enough. So that's done. Let's check out the softer side of things. So for this project, of course, I'm going to be making the RepRap Arduino Mega Pololo Shield, aka the RAMS. The RAMS 1.0 or the RAMS 1.2 in this case that we're seeing right now was actually designed with this project in mind, with being a simple board that you can do with a pen plotter or other methods. If you look at the layout of the RepRap Arduino Mega Pololo Shield, you can actually see that most of the traces are happening on the bottom side, and all the red ones, those are the ones that would be on top, are, pretty sparse. It would be just 6 jumper wires or so to solder in, and that's something that you can very easily do once the board is finished as a single-sided PCB. Now, the process of getting from the Eagle design files to the G-code that the printer can actually run is almost identical to what we're doing for the CNC project where we mill out things. So basically you start out in Eagle, you export your gerber, you input that into FlatCam, and right here, there's the one single difference. Instead of using a positive tool diameter because you're removing material, we are using a negative tool diameter because we add traces, we paint on traces technically. I'm using a tool diameter of negative 0.45 millimeters because that's the correct size to reproduce all the traces on the RAMs. And I'm also adding 10 passes to make sure that we fill in all the big copper areas. From there, it's the same steps. We create the geometry, we create the G-code, and then export that, and we're off to the printer. So just like with the CNC, I'm gonna just tape this down to the printer's bed. Now with the CNC, this needed to be perfectly flat because there was no height adjustment and we needed to cut away and mill away the exact right amount of copper. With this, because we have that bouncy pen mount, we can be off by quite a bit and it should still turn out really nicely. It's probably way too much tape. So for this one, I'm actually using Prontoface instead of the Universal G-code sender because this, is better at talking to 3D printers. So if you do restart, this is actually going to do a dry run of our moves. There we go. Home position is totally off, but it's doing it. So let's stop this and set the home position correctly. I guess it can't really reach the X home. That's good to know. So one of the things I did here is I sent it a G92Z200. Basically, because a 3D printer rarely needs to go below the bed surface, if the machine itself thinks it is actually at that 0 level, it's not going to let you go down any further. So after booting up, the only way you're going to get the machine to move down is by homing. And I don't want to home it right now because that might crash things, I don't know. So with the G92Z200, I'm actually telling it, okay, right now you're at 200 millimeters height, and then I can move it down and manually adjust it to that level. Okay, and now we can tell it is, just slightly above the surface. I'm going to send it a G92Z, well, let's say 2. So right now it thinks this is 2 millimeters above the surface. We also need to tell it that it's now 15 millimeters in, that this is like the starting point. The Eagle files are kind of offset from 0, so we could either move this here and say this is 0. I think it's easier to just eyeball it like this and then go G92 X0 Y0, and that's going to tell the printer, okay, this is now your 0 position. So in theory, we should be able to hit print and it should draw out our PCB. It's drawing things. Look at that. Perfect. I may have gone a bit too close to the edge here. Let's restart that. So the good thing with these pens is that even though they are etch resistant, you can wipe them off really easily with acetone. And in fact, I think we should have just cleaned off this entire board with acetone before we got going, just to make sure that there's no greases or stuff on there that could keep the etching solution from working properly in those contaminated spots. But it does look like the isolation width is actually okay, that we are getting some isolation between the individual pads. That is actually looking pretty promising. All right, but this is going to take a time, so time lapse. Okay, so honestly, I actually think this looks better than what I was expecting. I mean, it does look extremely clean. However, if you look at the details, I mean, I'm not talking about the details over here where the font didn't print, but down here, there are some points where the gap between two adjacent traces is kind of too small for my taste. But it's actually not a problem if these are slightly off center. That doesn't matter too much, but the fact that these kind of make contact where they shouldn't be making contact, that does worry me. So this one has been drawn out with the Staedtler pen, which I'm using specifically because it is supposed to be really etch resistant. So when you dump this into the etching solution, it doesn't wash off. But I've also heard that these Faber-Castell Echo Pigment, these are pens that you'd use for doing drawings, 2D drawings basically, are also pretty nice for this. And the smallest one of these that I have is... oh, I've already scraped it off, is 0.3 millimeters. So that's, I think, a bit finer than the Staedtler one, which is around 0.5. So this should give us a bit more detail and a bit less wide tracks when I do a second one over here. So let's go ahead and try that. And that's not going to be enough space to draw out the entire layout again. Oh yeah, like this is really a lot finer. This is the second pass, so it's kind of scraped off some of the ink from the first pass, but the traces themselves are not overlapping all the way, so I'm gonna have to redo this G-code and kind of add some more overlap between the individual passes. Also, the pen is kind of lifting over here. Oh no, oh no. You're not supposed to start there. I also dropped some acetone into the reservoir of this pen just to make sure the ink is like flowing really well. We're gonna see whether that actually did something or is now just dissolving the pen from the inside. But, well, I'm gonna drop you all into time-lapse and you guys can watch whether this works out or not. So with the finer pen, we are definitely getting much better resolution. And if you look at the gaps here between the ground plane and the individual pads, these are much nicer and much clearer. And, you know, you can see even the text turned out pretty well. But, you know, looking at this, I don't think this should be backwards. I think I actually printed this out the wrong way around, because typically this layout is if you X-ray through the top onto this, but we're directly printing onto the bottom. Oh well, live and learn. Next time I'm going to remember to actually flip this before plotting it out. So before I go ahead and etch this out, I actually want to cut away all the copper that's not going to be part of the PCB, because if I leave all this copper on there, it's just going to use up the etching fluid much faster. So the best way to cut PCBs would actually be by using shears, but what you can also do is you can just score it really well from both sides and then just break it apart. Okay, so we are ready to etch these two PCBs. Now, of course, these aren't perfect. These are like a first try for me, and hopefully you guys can learn from my mistakes here. But nonetheless, I think these two should still turn out pretty nicely. You can already see that the copper is starting to turn into a much brighter pink shade, which means the etching solution is already starting to work. So yeah, that's going to take a while to etch, so while we're waiting on that, let me tell you about today's sponsor, Skillshare. So Skillshare are a recurring sponsor on this channel and on other channels as well, which is awesome, so big thanks for that. And they are an online learning community for creators. They have over 26,000 classes in business, design, and pizza baking. You can go in, you can watch classes at your own pace. One of the courses I want to recommend on Skillshare is by Mark Frauenfelder, founding editor-in-chief of Make Magazine, and he has a course on Arduino. Hold on. All right, so I think we're done with this one right here because it's just, oh yeah, wow, there's like nothing staying on here. Okay, so the ink in this pen, not very good for this etching process, not very good for this etching solution either. Now the other one from the Staedtler pen looks like it's holding up just fine. Now of course, there are going to be flakes that are sitting on this, so I'm going to have to agitate this regularly, but at least it's much better than this. Alright, so we've got that fixed. As I was saying, one of the courses I can recommend on Skillshare is Introduction to Arduino, Creating Interactive Projects by Mark Frauenfelder. And if you've never done your own projects with Arduino, it's not that hard, and Mark gives you that kickstart to starting your own interactive projects, because those are the best ones. With any electronics project, you need some sort of input and some sort of output. You know, that's what makes a 3D printer fun, if you get that output, and it's the same with Arduino. So check that course out. Anyone can learn Arduino. And to help you try out Skillshare, they're giving away a free 2-month unlimited access trial to the first 500 people who click the link in the video description below. After that, it's only about $10 a month in the annual subscription. So try them out, whether it's just for your curiosity or for your career. Keep on learning, and thank you Skillshare for sponsoring this video. Yeah. Okay, I made a new one. As you can see, I've got my etching setup ready here. This is kind of moving back and forth. It's also heated to 45 degrees. With those first two PCBs, I actually wanted to see how the ink would behave in that etching solution, and we can actually see that the echo pigment wasn't behaving so well. It was all peeling off. That might be because this one was stretched with acetone, and this red Staedtler pen might have been too old. I don't know, so I used a fresher black Staedtler pen with this one. I think that should work as well, and it should stick on here pretty well. I also cleaned it off with some steel wool and gave it a bit of texture, so this ink should grip onto this PCB pretty well. So right here we have our agitator and heated surface. This is set to 45 degrees. I'm going to let this get up to temperature for a bit because 45 degrees or 40 degrees, somewhere around that, is actually like the perfect temperatures for etching PCBs. Oh yeah, that actually sloshes around pretty nicely. The black particles really help show where the fluid is moving. Okay, so that is probably going to take a minute to heat up. We can see the bed is nice and warm at 46 degrees, but the etching solution itself is actually just borderline like 18 degrees. So that's going to take a while to heat up. And I think we're good. Let's pause this. And let's grab this PCB. Oh, this is nice and warm. Let's check it out. Yeah. And dump it into some water to neutralize the etching solution, or at least to wash it off. It doesn't neutralize it. There we go. So here's our PCB. Now, first of all, ignore this area up top here. I just didn't want to wait until this was all etched out. But there are a few things wrong with this PCB overall. Now, the first thing you're probably going to be able to see, and you can see it down here really clearly, is that the pen didn't provide a ton of resistance against the etching solution. You can see the individual traces of the pen where, you know, that the 3D printer was plotting out its traces and then kind of overlapping it. It looked to me as if this was a solid cover, but apparently the etching fluid back there was attacking the pen's ink and kind of eating it away or kind of dissolving it. I don't know what exactly was happening there. So you really need a thick cover of ink on these surfaces to get a really nice resist on this to make sure it doesn't etch through. Now, of course, you may just say, oh yeah, this is over-etched. You left it in there way too long, but you know, you can see this area up here. Let's just ignore that for now. But this didn't get etched away all the way. And also looking at the time lapse, this was just a minute or two after all the copper bits between the traces that I wanted to keep were etched away completely. So this is So this is actually pretty close to the ideal etching level that you want with these PCBs. Now, what I'm surprised about is that even though this distance between these pads and the ground trace above it is pretty thin, and that distance is actually pretty close in the CAD files and the Eagle files as well, it looks like we do have good separation there. It doesn't look like there's a short between the pads and the ground trace above it. So that's really nice to see. But overall, with this pen, with the black Staedtler that I was using in this setup, this is just not usable. I mean, you can see where the traces are supposed to go, and some of them are actually pretty nice, some of them are pretty consistent, but overall, the pen just didn't cover up well enough. Now, there are specific pens that are made for this process. I mean, they're not made for a CNC plotter, but they're made to draw out traces by hand. But I guess you could use them in a plotter as well. So those are probably something that would work a bit better. Maybe even just a fresh one of these Staedtler permanent red ones. The red one actually seemed to work pretty well. But another issue that I was seeing in some of the plots, not all of them, I guess it depends on how hard you push down with the pen, was that this setup, because it is not totally rigid, it does kind of wobble around. It looks like it was creating imperfections in the actual plot before we even start etching. So you might see, well, first of all, these tips are rather large, and you can't really draw every thin trace with these 0.5 roughly millimeter tips. You do really need a finer tip. But also, if you don't have the precision to control where the ink is going, you might get some areas where the spacing is off between pads. You might get some areas where there's shorts between individual traces. I don't know, I think it's pretty tricky to figure out. This mount as well, the bearings aren't totally smooth. They kind of bind sometimes. I think that the rubber is also too tight on this. And this does create a ton of pressure on the pen's tip, so you do get a pretty wide area where it's painting down. But of course, one issue that still remains, even if you have a PCB like this that has all the traces on there, even if this was perfect, you would still need to drill it, unless you're doing all SMD designs where you just have components on the copper mounted directly to it. If you have any components like, your regular through-hole resistors or ICs or anything like that that goes through the PCB, you will need to drill holes for those. And because we can't really drill holes in a 3D printer, it's not made for removing material, this would either need to go to a drill press. You need a drill press that has really high RPM to make clean cuts in this material with the small drill bits. Or you need a CNC. You need some sort of CNC router with a drill bit in it, and then you need to align it in that machine. There is that fiducial on here that kind of helps you align this PCB in another machine. But that's of course something that is kind of tricky to get perfectly right. And drilling it by hand with, I don't know, 50, 60, 70 holes on this thing is going to take a while, and you're not going to be perfectly on point with that. This one does not have any sort of indicator where holes are supposed to go, and especially in this area right here where there's kind of solid chunks of copper and there's supposed to be a MOSFET going through, there's no indication of where those holes are precisely supposed to go. So unless you actually drill out kind of a template for yourself and stick that to the top and then drill through that, it's going to be really hard getting these holes on point. So even though this was a really fun learning process and kind of figuring out the cam for this and attaching stuff to a 3D print and making it do something else that it wasn't intended for, I don't think I'm going to be using this process again. There's just too much stuff that can go wrong. And of course you do have to deal with an acid that etches away the copper. And this is a toxic fluid now. It's not just corrosive, but it's also toxic because there's now copper dissolved in it. So from where I'm standing right now, and with the success and failures I've seen with this process, I think a CNC-based process where you actually have a cutter in there is the more reliable and the more reasonable option. Even though it is louder, it's messy, and you need a specialized machine for it. But at the Make Munich, I've seen the Ant CNC, which is just kind of it's that size, which is a Core XY kind of motion platform. It has a super tiny cutter head on it, and it was making PCBs that looked absolutely perfect. So stay tuned for the video of that. I've got so many machines that I want to make right now. But yeah, That's an interview that you should definitely check out, and I'll link to it up, I think, this corner. Yes, I'll link to that up here once that video is out. But of course, prototype services where you get an actual real PCB, an etched PCB, 2, 4, how many layers you want, within a few days have also come a long way. So you can order those, and those are going to come out perfect. And you don't have to do anything when it comes to etching or milling or doing anything like that. You just get the finished thing. So that's probably a more reasonable option for most people, unless you really need that PCB right then and there, or you really need to iterate quickly and make a few changes and be able to instantly mill out a new one. Even though those prototype services are quick now, they do still take a few days to get that PCB to you. And of course, if you have a CNC workflow and the machine for it that works well for you, that's going to be way cheaper than ordering those every single time, because the raw material, these PCBs, even if they're dual-sided, don't really cost a whole lot. But lastly, I don't want to totally bash on this setup, because there is one thing that I think it could do pretty well, and that is the solder resist. And the solder resist basically makes sure that your solder only goes where it's supposed to be. So if you solder to one pad, that it's not going to bridge over to that ground plane that's right next to it. You may even just be able to use these Staedtler pens. I'm sure having some sort of ink over the areas that you don't want solder to stick to is better than having nothing at all. So these were my attempts of making PCBs with a 3D printer and a plotter. I hope you learned something, and if anything, I hope you don't make the same mistakes I made. If you enjoyed the video, give it a thumbs up. If you want to see more stuff, subscribe and hit that bell. That's also kind of important. And if you want to support the channel directly for more nonsense and experiments like this, Patreon or the YouTube memberships, that's the join button under the video. That helps out the channel directly, so huge thanks for that. Yeah, thanks for watching, and I'll see you in the next one.